Okay, so this is a continuation of the discussion for the double integration method. So, like what I've said, if a beam is divided into 3 segments, now in this example, the 3 segments are this one, A, 2, 3. Now, instead of writing 3 different moment equation, all we need to do is cut it at the last segment. So this is how it should look like. And then after that, nakukunin natin yung moment equation. Di ba magkakaroon tayo ng, magkakaroon tayo ng moment equation dito. Now again, to get the moment equation para mas madali, di ba dito tayo magmo-moment. Dito yung moment, no? So, yung 78, opposite yung rotation niya sa M. Kasi pag ganito yung M, counter, yung 78 is clockwise, so positive. Distance niya is X. Yung 60 naman, ang distance ng 60 is, if this is X minus 2. Ito naman 75. This will be X minus, ilan to? 2 plus 4. This is X minus 6. Diba? Ito. Now, yung 60, same rotation sa M. So, minus. Yan, minus. 75, same rotation sa M. So, minus. And then, multiplied by the moment arm. So, we have here your moment equation. So, again, if lilito kayo dito, pwede naman na isulat nyo yung moment equation. No? Basta dito kayo mag-moment kung saan kayo nag-cut. Now, if you want a shorter, tingnan nyo lang yung FBD, then write down the equation. Now, again, first integral is your slope. The second integral is your deflection. So, all we need to do is integrate the moment equation. Now, since this is a shorter version of the double integration of getting your moment equation, ang pag-integrate natin sa kanya is as a whole. Ito, instead of integrating it per constant, no, dapat hindi natin gagalawin yung nasa loob ng bracket. So, example, ito na, 78x minus 60 times x minus 2 minus 75 times x minus 6. Yung pag-integrate natin is itong per segment nung beam. So, we have 78x naging squared over 2. So, naging 39. Ito, 60 times x minus 2 squared over 2. So, divided by, naging 30. Then, again, x minus 6 raised to 2 over 2. So, you'll have 37.5. And then, if this will be your theta, then integrating it again, you have your 39x squared over 3, then 2 plus 1 cube. Kaya nagiging 39 over 3 is 13. Similarly, ganun ulit, over 3, tas magiging cube to. So, yun na, 10x minus 2 cube. Then, divided by 3 cube, tas naging 12.5 plus C1x plus C2. Now, remember, yung pag-integrate na ganito yung way, this is only if nag-shortcut tayo, yung isang cut lang sa segment. Unlike yung previous example ko, di ba, sa cantilever beam, ang pag-integrate natin is isa-isahin natin lahat ng may x or lahat ng constant. So, important yan na hindi nyo ma-interchange. So, let's see. Now, we have here the general equation for your y. Now, next, we will compute your C1 and C2 based on the boundary conditions. Now, here, based on the figure, we can say that at x is equal to 0, y is equal to 0, at x is equal to 10, di ba? Dito naman yung y is equal to 0. So always look at the figure. It's not always na nasa both ends yung 0 yung y. Kasi example, yung support mo sa B is nandito. Yung support mo is nandito sa B. Example lang. If nandito yung support mo, di ba, ang magiging itsura ng deflected shape is ganito. So therefore, ang y so 0 mo is nandito. So ang x na gagamitin mo is 6. So wag tayong para magpa-familiarize na dapat magkabilang dulo. So you need to check the deflected shape of the beam. And then tingnan nyo kung saan ba 0 yung y, and then yun yung gagamitin yung value yung x. Okay, so solve na natin. Ayan. So this is the equation. Now, boundary conditions, x is equal to 0, y 0. Then substitute natin dito sa equation. Na-substitute natin sa equation. Ito 0 na din. 0, 0. Tapos x is equal to 0. And then, yung rule pala is if, ganito kasi shortcut to, di ba? Yung lahat ng nasa loob ng parenthesis, if i-substitute mo yung value nung x and then ang lumabas is negative, ini-neglect mo siya. Nandito yung note. Ito. Ayan, note, quantities inside the bracket symbol must be ignored for negative values. Now, in this case, if magiging 0 yung x natin, ito, di ba? Pag maging 0, to magiging negative, so neglect. 0 magiging negative 6, so neglect. Similarly, ito naman at x is equal to 10, y is equal to 0. So yun, 0 na yung y. So we have, sorry, hindi 0. Tama, y is equal to 0. Then substitute nyo lang yung value ng x as 10. Dito sa equation na to, ito 0 na to, no? So yun, substituting the value of 10, wala namang negative yung nasa loob ng bracket. So lahat sila consider. The value of your C1 will be negative 708. And then substitute this value dito sa C1. So we will have your general equation. Ito na. And then the question is, what is the deflection at the midspan? Midspan is this point. X is equal to 5. So all you need to do is substitute 5 dito sa x. Kung mapapansin nyo, ito na 5, 5 minus 2, ito 5 minus 6, so negative 1. Neglect ulit to, so hindi nakasama tong part na to. Then, minus 708 times 5, so this will give you this answer. Okay, so ang maganda sa double integration method is kukuha ka ng general equation tulad ng sabi ko, and then all you need to do is substitute kung saan portion yung hinahanap. Kunyari, what is the deflection at this point? Di substitute mo x is equal to 2. Just make sure na double check nyo yung pagkuha ng general equation because mas madaling magkamali minsan pag mahaba yung equation. Double check lang lagi para hindi mamali. Okay, so ayun na, y is equal to negative 2 and 8.5. So, pag slope naman, ang gagamitin natin equation is yung isa. Diba yung isang equation? Balik tayo. Since y deflection, kung slope yung tanong, ito yung gagamitin natin. This is your slope. Ito naman yung equation na gagamitin. First deflection is slope. Second deflection is ito. Deflection. Okay, so another problem, using the double integration method, locate and compute the maximum deflection of the beam given in the previous problem. Okay, so if mananotice nyo, hindi siya symmetrical, so we don't know where exactly is kung nasan yung maximum deflection. Kung nasan yung lowest point dito sa curve. Now, first, eto na yung moment equation ng kanina, no? We don't need to get the moment equation. Parehas lang naman yung M. Now, kung ipo-portray natin, kung nasan ba yung maximum deflection, obviously it is somewhere here siguro. Hindi lang natin alam yung exact location. Pero nandito siya, imposibleng lumagpas siya sa 75. Now, since ang distance ng x is between 0 to 6, no, ini-neglect natin yung x minus 6 natin. Itong x minus 6, ini-neglect natin siya. Because the value of x is between 2 to 6. So, hindi na natin ito isasama. Neglected na siya. So, ang equation lang na gagamitin natin is ito, then C1. No, bakit yung sa slope yung ginamit natin? This is slope, di ba? If you recall, I told you dun sa previous lesson na the point of zero slope is the point of your maximum equation, deflection, di ba? Sabi ko, habang pumupunta tayo sa point of maximum deflection, nagiging horizontal line siya. So, isa-set natin as 0 yung slope. Gawin natin 0. So, pwede tayong makakreate ng equation using this one. No? Gagawin natin siyang 0. So, ito na yung lalabas. Ito na yung lalabas, no? 39x squared minus 30 times x minus 2 squared minus 708. Okay, so, ito yung equation natin. Now, kung mapapansin nyo, ang unknown lang dito is yung x. Diba? Since yung theta natin, ginawa nating 0. So, pwede nating makuha yung x. Now, yung x na makukuha natin dito, this will be the location of your maximum deflection. So, ganun yung ginawa, no? Kinapi natin yung formula, general equation for your slope. Eliminate natin tong x minus 6. And then, substitute nyo 0 yung slope kasi tulad ng sabi ko nga, point of zero slope is your point of maximum deflection. And then get the value of your x. Ito na. Simplifying this, let's see. Yan, simplifying, pag-expand, you may use the quadratic equation. You will get the value of your x. So, yun na. Ang point of maximum location will be 5.014 meters. So if this is 6 meters, it will be somewhere around here na 5.014. So ang gitna niya is 5. Kung mapansin niyo, konti lang yung difference. Ito yung gitna 5, pero andito yung point of maximum deflection. So dapat mas mababa yung point niya kaysa dun sa gitna. Now, all you need to do is substitute this x dun sa general equation natin to get the value of your y. Now, please take note, do not eliminate here yung x minus 6. In-eliminate lang natin yun dun sa una because we want to get the value of your x. Now, part pa din siya ng general equation. So, dapat kasama siya. Ayun na. Once we get your x, we can now compute for your y. Now, sa any problem, kapag simply supported siya or overhang beam, if you want to locate your x or the point of the maximum deflection, if you want to locate the point of maximum deflection, ang gagawin nyo lang is, palagi nyo lang isi-set as 0 yung slope or theta para isa na lang yung ano nyo and makuha nyo yung variable x. Now, if ang problem is, for example, cantilever beam, tinatanong kung ano yung maximum deflection. Obviously, ang maximum deflection ng cantilever beam is sa dulo. Kasi ganito lang naman ang shape ng deflection niyan. Always, kapag cantilever beam, nasa dulo po ang maximum deflection kasi ito yung pinakamataas yung deflected part ng beam. Okay, so, ayun na. And then, last problem. Okay, we have here, again, a simply supported beam. And then, subjected to uniform load and a concentrated load 2 meters from the left end. Now, if you'll notice, this beam is divided into 2 segments. Segment 1 and segment 2. So, we need to cut it at the second segment, which will look like this one. Yan. And then, kukunin ulit natin yung ating moment equation. So, hindi ko na dinodrawing yung FBD na. Tingnan nyo na lang siya dito mismo. So, you have here M. So, para di kayo malito, lagay nyo muna yung moment arm. So, yung X. So, if this is X minus 2. And then, so, yung moment, diba, 87 times X. Opposite sila, opposite sila nung M. So, 87X minus same direction, 45 times X minus 2. Naka-bracket ulit siya. And then, we have 24 times X times the moment arm. X over 2, kaya naging 12X. Shinartcut ko na, no? Ang mangyayari dito, minus 24 X para maging concentrated load times the moment arm, half of X, so X over 2. So, kaya siya naging ganyan, 12X squared. And then, ulit na lang ulit, i-double integrate natin, copy the moment equation. You have 87X minus 45X minus 2 minus 12X squared. Integrate first, so squared over 2, kaya nakalahati. 45x minus 2 over 2, then 12x 2. So, magiging 3 over 3. So, kung mapapansin nyo, dinivide na natin sa 2 saka sa 3. Ito na. Then, after that, integrate nyo ulit. Ito yung slope ulit. This is your slope. Then, integrate yung isa pa. So, squared, this will be cube over 3. This squared, this will be cube ulit over 3 naman. And then cube, this will be 4 over 4. Tapos simplify, ito na yung lalabas na sagot. Please always remember kasi there are times that students forget to integrating constants. Yung C1, do not forget. So C1, yung second, pag integrate mo siya, magkakaroon siya ng X. So this will now be your general equation. And then, boundary conditions, balik tayo dito sa itsura nung deflected shape. Diba? This will deform this way. So, meron tayo y dito sa support, y din dito sa support. So, at x is equal to 0, ito naman x is equal to 5. Again, this will be used to get the value of your C1 and C2. Check natin. Ayun na. So, at x is equal to 0, y is equal to 0. Yun na. Tanggalin natin to. And then 0. Again, neglect kasi negative yung lalabas. 0, 0. So, yung C2 natin is 0. And then at x is equal to 5, y 0. 0 siya. 5. 5 minus 2, positive. So, kasama. 5, 5. So, makukuha natin yung value ng C1. And then, pag makuha yung C1, substitute nyo lang sa general equation. So, ito na, nandito yung equation ng theta. And then, equation ng deflection. Now, ang tanong is, compute the slope and deflection under the 45 kilonewton load. Na yung position niya is at 2 meters. So, substitute lang natin yung 2 dun sa equation. Substitute nyo lang yung 2. So, ito na, substitute lang yung 2. Sa slope equation, ayan, makukuha natin yung theta. Substitute nyo yung 2, you will get your deflection. Okay, so that will be this is the last example, I think, yan. This is the last example for the double integration method.